Welcome to this explainer on agentic engineering. Today, we're taking a massive leap in technical capability. We are diving straight into day 11 of the curriculum, and it is entirely dedicated to mastering one incredibly powerful concept, RAG, or Retrieval-Augmented Generation.
So think about this. How does an AI actually read a massive document? I mean, we already know about the strict limits of context windows, right? An AI model just can't hold an entire specialized custom library or a giant stack of dense research papers in its immediate processing memory all at once. It's just not possible. To get it to effectively read, really comprehend, and accurately answer questions about your massive custom datasets, we have to build a specialized architecture around it. And resolving that specific memory limitation, well, that is exactly what today's lesson is designed to do.
Here's our quick roadmap for today. We'll start with day 11, Agentic Engineering, then move into understanding RAG, learning embeddings, vector databases explained, the retrieval process, and finally, our project, building a PDF chatbot. All right, let's kick things off with Section 1, Day 11 of Agentic Engineering. Like I mentioned, today is entirely dedicated to a single, absolutely game-changing framework, RAG. Everything we cover from this point forward is laser-focused on giving you the exact understanding you need to execute this protocol completely from scratch. Moving right along to Section 2, Understanding RAG. To really master RAG, we have to clear 3 sequential hurdles. Step 1 is embeddings, Step 2 is vector databases, and Step 3 is retrieval. And, each step feeds directly into the next. You literally cannot build a successful RAG application without getting a really solid grasp on every single one of these components. Which brings us to Section 3, Learning Embeddings. Okay, so embeddings are absolutely crucial. They're the foundational process of translating human information into a mathematical format that an AI can actually compute. Think about your source document for a second. It's filled with English words and human concepts, right? But AI models, they recognize numerical patterns. So by turning text into embeddings, we're basically converting our massive document into a vast array of mathematical coordinates. And we aren't just talking about a simple 2D graph here, no way. These models map concepts across thousands of dimensions to capture really deep semantic relationships. It completely bridges that gap between human language and machine computation. Now for Section 4, Vector Databases Explained. If embeddings are our inventory, then the vector database is the warehouse keeping it meticulously organized. Think about it. Once you've mathematically translated all that dense human information into complex coordinates, you need a highly specialized place to put them all. Standard relational databases? They just aren't built to efficiently handle this kind of crazy multidimensional mathematical data. Vector databases, on the other hand, are designed specifically for this exact task. They organize those thousands of dimensions so that similar concepts are logically grouped close together. This optimizes the entire warehouse for massive-scale, rapid searches. Let's jump into Section 5, the retrieval process. Retrieval is basically the dynamic plumbing connecting our stored database securely back to the AI. It's the active mechanism required to fetch the right stored information at the exact right time. When a user asks a question, this retrieval mechanism acts like an incredibly fast courier. It takes the user's prompt, dips right into the vector database warehouse, finds the mathematical embeddings that most closely match the question's coordinates, and pulls only that highly relevant context out. It's literally the engine that powers the R in RAG. And finally, Section 6, our project, the PDF chatbot. So how does all this translate to code? Well, every theoretical step we just talked about serves a deeply practical purpose. Your knowledge of embeddings allows the AI to parse and read the specific PDF mathematically. Then, the vector database becomes the active storage architecture for that PDF data. And finally, retrieval is implemented as the actual chatbot mechanism, fetching the correct answers to seamlessly reply to a user prompt. By stringing these 3 steps together, you've just engineered a customized PDF chatbot from the ground up. You've actually solved the problem we posed at the very beginning of this explainer. You've given an AI the architecture it needs to dynamically read, reference, and discuss a massive document, all without overloading its core memory limits. It's really cool when you see it all come together. The foundational pieces of RAG are now entirely in your hands. You know how to translate, store, and seamlessly retrieve custom data. So the only question left is, what intelligent, context-aware system are you going to build next?